talking about vegetative environmental buffers in regards to air quality, and what I'm talking about today is based on experiences here in Iowa, both from a research as well as an extension perspective. And every site is its own site, and it has its own characteristics. It has its own landscape. It has its own airshed. And so, the correct VEB is really a site-specific issue. There are some blueprint generalities that can be applied to this concept, but we generally do site visits. We always take into account the goals of the producer. Are they looking for visual screening? Are they looking for true filtration? Do they want snow management? What do they want? We look for functional zones where we're going to try to enhance dilution effects and interception effects. We definitely look for sight lines. Where are the roads? Where is this facility visible so that we get appropriate species for visual screening? And then, of course, the big one is create no hazards, snow deposition problems, ventilation problems. In a naturally ventilated system, that's really critical. You got to have that airflow in the summertime. If you're a mechanically ventilated system, you don't want to have those trees too close because it's going to cause back pressure and increase your energy bills. And so, again, create no hazards. You also don't want to put trees. They're going to cause visibility issues on site. You've got a lot of trucks coming in and out. Just very briefly, thinking of functional zones, here's a belt that might be appropriate for this kind of a naturally ventilated system. Notice that there are some general rules of thumb here. We've got some distances that might be considered minimum distances from the building so that they're not too close and is going to cause a snow deposition area. Of course, depending on the species that you use and the spacing between trees, you can have them at variable distances. So here, if you wanted to have some southern coverage, but we're concerned about summer ventilation, you might have some very wide spacing. So you still get a little bit of continuity from a visual perspective, preventing some of the particulates from moving downwind from the facility across this area and picking up VOCs. And here in the corner, these are wind roses, and what these are basically, maps of the prevailing wind. And so if you look at the June and August, this is for central Iowa, what the length of these lines and the direction indicate where it's coming from and where most of the wind comes from during these time periods. So from June to August, we get mostly southerly winds. So, you want to plant trees to definitely account for your prevailing wind systems. In the wintertime, the November through February perspective, the wind rose flips in Iowa, and so most of it's coming from the north and the northwest and the northeast. So again, from a snow perspective, here's that functional zone, that location area. From a summer standpoint, where you generally do get most of the odor complaints because people are outside enjoying the day, and you definitely want to have this functional zone for creating dilution and for interception effects, and as the wind blows through the building, picking up VOCs and pushing them on downwind. You can even throw in the secondary snow fence. Maybe you're throwing in a different kind of species, like a shrub species. You can have some sort of landscape architectural perspectives as well, if you wished. Now, to talk a little bit about economics, just like the effectiveness of a VEB, the costs are also highly variable and definitely site and design specific, but there's always sort of these three main categories. First is the site prep costs. A lot of these sites, particularly on retrofits, these are essentially construction zones, right? And you've got a lot of compacted soils, you've got former roads, you've got areas that have been in sod for a long period of time, and they really need site prep. You just don't plunk a tree and expect it to grow for the long term. So there's always going to be some site prep necessary. Tree stock and establishment costs, so actually buying the plants, that's usually the biggest cost, and then planting the trees is also a big cost. And then, of course, there's the long-term maintenance, which is absolutely necessary to keep the trees healthy, to keep the site looking good. So we're talking mowing, we're talking pruning, we're talking replacing trees that are unhealthy or, dead or dying. And I'll touch on these in a minute. But from an economic standpoint, so here's that demonstration site I just showed. 3 different species, the Austree willow, the red cedar, and then this red osier dogwood, which is a nice shrub species. Here's the number of trees that might go into this system. Here's the general unit costs of these species, some notes about the kind of plant stock that's involved here. And so here's what that translates in terms of costs. A lot of farmers want to know what it's going to cost them up front, so I crunched these to give you that perspective. I analyze costs over a planning period, say a 20-year period. That's sort of the general length of time that buildings will be on site before they really need refurbishing. And it's also sort of the length of time for some of these species. Austrian willow, for example, has a 15 to 20-year lifespan before they start to fade a little bit. So over a 20-year period, I've calculated costs, but the upfront cost $740 to put this in, which represents about 40% of the total 20-year costs. Our producers like to hear about these things on an animal basis, and so thinking from a pork production perspective, total costs per pig over a 20-year period come to about 3 cents a pig. Think about this from a capital recovery or an annual cost perspective, about $160 a year over that 20-year period. If you're in a part of Iowa or part of the country that has dry soils or dry climate and rapidly draining soils, and irrigation might be a side thing that you'd have to throw in. So just an example of how some of these other issues might play in financially. With extensive drip irrigation, it adds not even a penny to the total cost on a per pig basis. Site prep. So this is getting into some of this and what's involved. Proper site prep, and you just cannot overemphasize this. If you do it right, it's going to reduce tree mortality. It's going to increase tree growth, sometimes upwards of 70%. But ultimately, it's going to reduce the time, money, and effort that goes into dealing with these systems. Something definitely appealing to producers. So, proper site prep, again, it's going to vary, but it might be as elaborate as a 2-year process. The year before you plant, you might go in. If you're dealing with a sodded area, you have a kill strip, you're using chemicals, you're going to go in with equipment and disc and cultivate the area. The following spring, you might go back in and disc and cultivate it again, maybe even rototill it to really get this soil suitable for receiving trees. If you contract it out, most of those folks know exactly what goes into this to ensure long-term tree health. And this is just to give you a perspective on what could be involved. Tree care options, again, here's that drip irrigation example. You've got, all you need is a main line of water, a water supply, and you've got the main line to run basically hoses in and around the trees. You can see an example of this. Most of us know drip irrigation. And in certain parts of the country, this is going to be necessary to keep those trees alive. Once they get a little older, they become more hardy. Dealing with weeds is a big problem, especially in the early phases of tree development. They can easily outcompete seedlings. So there are chemical approaches. There are different kinds of biodegradable materials that can go into the ground that trees can be planted into that keeps weeds down. Each individual trees can have, different kinds of mats. And so we've got trials as well as colleagues in Delaware that are looking at these kinds of things and looking at the different kinds of potential cost streams associated with weed control.